Aquatics, Mrs. Kane here. So I just want to take you guys through some density examples, especially because it's a little bit different doing the math versus what we do in lab. So first thing I would like you to review is our density equation. So we have density is equal to our mass in grams divided by our volume. So our volume can have several different situations. So if we have an item that is like square or rectangular, we are going to be figuring out our length times our width times our height for our volume, and our units will be centimeters cubed. Or if we have a liquid, it will be in milliliters. Okay. Or if we have a weird shaped object, we're going to use what we call water displacement, which I'll show you in a little bit. And so our volume will also be in milliliters. So for those of you who need a little bit of help rearranging the equation, here's our triangle. Okay, so remember when we're using this, cover what you're looking for. So if I'm looking for density, it's going to be my mass divided by my volume. If I'm looking for volume, it will be our mass divided by our density. And if I'm looking for mass, it will be our density times our volume. Okay, so I'm going to walk you through what it would look like in a lab situation. Okay, so here's my cube. All right, so if I want to know the density of this cube, the first thing I'm going to do is take my ruler. Okay, make sure you got it on the centimeter side, and we're going to measure. So this cube is, can you see that? 2 centimeters across. Okay, since it's a cube, it will also be 2 centimeters down. Okay, and our length will also be 2 centimeters across. So what that looks like when we're doing the math piece, okay, we got our length times our width times our height. So we have 2 centimeters times 2 centimeters times 2 centimeters. So 2 times 2 times 2 gives me 8. We also multiplied those units. So we have centimeters cubed. Okay, because we multiplied centimeters 3 times. So that's our volume. Okay. Then we're going to come back over here to my cube. We're going to grab the cube and put it on my scale. Okay, so 145.2 grams. All right, so here is what my math would be set up as. I've got that 145.2 grams that I got off my scale, and I have my volume, the 8 centimeters cubed. So we got this number by multiplying the length times the width times the height. So now we're just going to plug in, okay, or do a little division in our head. So 145.2 divided by 8 is going to give me about 18, okay? Keep an eye on your units for density. You're going to take your mass unit, which is grams, and you're going to divide it by your unit for volume, which this case was centimeters cubed, and that is your entire unit for density. Okay, so now I'm going to take you through and do an example of how we would figure out an irregular shaped solid, okay? And we're going to figure out what its density is. My irregularly shaped solid is my nice little bell. So first thing we're going to do, we're going to put it on the scale. Okay, so it's 6.1. So that's our mass. Then I'm going to grab my graduated cylinder. Okay, and you can see that I've already put a certain amount of water in here. So our amount, if it will focus for me, is 50 milliliters. So that's what we're starting with. Okay, so if I am doing the math bit, give me a second, let me grab my marker. Okay. We're gonna write this down. So our mass, which goes on the top, was 6.1 grams. Okay, and so far we don't know our volume. Okay, but what we do know is that I'm starting out with 50 milliliters of water in my graduated cylinder. Okay, so now we're going to come back over to my graduated cylinder, and we are going to put the bell inside. Boop. There it goes. Give it a second to settle down to the bottom. Okay, and now we are going to revisit. Let's focus. Okay, we're going to re-look. And when you're reading this, Okay, make sure you read from the bottom of the meniscus. Okay, so that's the bowl-shaped line. So we're reading from the bottom. Okay, so if we're looking at that, it actually went up from 50 to 54. Okay, so now we're going to come back to our math. Okay, so we started out with 50 milliliters, but we went up to 54. Okay, so we're just going to subtract those two numbers. And when I do that, I get 4 milliliters. So keep in mind, we started with 50, so that's just the water. It went up when I put that bell in to 54. So if I subtract those two, I get only the volume of my bell, which is 4 milliliters. So now I'm going to come back over. Okay, and we're going to erase our question mark because now we know that we've got 4 milliliters. Okay, so we got 6.1 grams divided by 4 milliliters. Okay, so either doing a little bit of mental math or plugging it into your calculator. So we should get about 1.5. So our density, okay, that's our number for our density, 1.5. But now we need to go back and look at those units. Okay, so this time we have grams and milliliters. So our unit for density would be grams divided by milliliters. So there's our answer. Okay, so just a quick overview of some of the different ways we can do this. If we were doing it with just a liquid, you would not subtract. You would just use the number off your graduated cylinder as your volume because it's a liquid. Okay, guys, I hope that cleared up some of our questions. I promise you we will get some more practice, okay, especially with that water displacement. So make a big old star in your notes next to that one because we are going to be seeing that on some exams that they got for us, okay? So keep an eye out. We'll get some more practice. If you need any help, come to office hours, shoot me an email. Let me know how I can help you guys. All right, bye.